Hey, what's going on, guys? It's Anson here. So we're back with a brand new video, and I'm going to talk about functions. I'm going to show you guys some examples on why functions are important in programming. Let's say if we want to add all numbers from 1 to 100. So let's just do that real quick. We did this implementation in the previous video. So we're just going to go ahead and declare two mutable variables. One is going to be the accumulator. The other one is going to serve as a counter to keep track of the current state of the loop. So that way we know when to actually execute the loop. So we're going to go ahead and let's just declare another variable, call it n. And this is just going to be 100 because we want to sum all numbers up to from 1 to 100. So now we're gonna use the loop keyword, and inside the body of our loop, in between these curly braces, we're gonna specify an if statement, and we're gonna go ahead and check to see if counter is less than or equal to n. And if this condition is true, that means we want to add counter with sum and assign that value to sum. Okay, this is basically going to add the next number every single time, and we're totaling up with the sum variable. Then we need to update counter by 1, so that way we can simply go to the next iteration. Otherwise, if we don't update counter, the loop is going to execute infinitely. Now, if this condition is false, we're just going to simply break. And if I just do a simple print ln and print out sum, the output of this code should just be 50-50. There we go. But let's say if I wanted to add all numbers from 1 to 1,000, we would have to kind of just copy and paste all this code all over again or rewrite everything. And we might want to reset sum back to 0 because we're trying to add all numbers from 1 to 1,000 now. And if we don't reset sum, it's going to add the next 1,000 numbers to the current value of sum, which is 50-50. Let's reset counter. Let's declare another variable called s and assign it the value of 1,000. And then we're going to check to see if counter is less than s this time. And now let's print out sum. And you can see that we have a new sum. We have the sum of all numbers from 1 to 1,000. But what if we wanted to add all numbers from 1 to 10,000, 1 to 100,000? We'd have to keep on rewriting this same code over and over again and change up only minor things. So what we're going to do is we're going to actually just delete all of this code now because we don't want to rewrite the same code over and over again just to sum all numbers. Let's put everything all in a function so that way we can invoke it later on whenever we want. We don't have to rewrite the same code. We can just write the code one time and then reference it later when we need it. That's the beauty of functions. We can declare a function and we can tell the function to do whatever we want it to do, and that function is going to return some kind of value. A function, all it is just some kind of subroutine that we can call later on to perform what we want it to perform, and in the end it can give us a value, or it doesn't need to necessarily give us a value. But in our case, we need our function to return the sum of all numbers from 1 to n. So let's declare a function using the fn keyword. Okay, we've been doing this over and over again with the main function. So let's just call this sum underscore to underscore n. And we're going to take in one variable and we're going to specify a pair of parentheses. Now inside these parentheses, we're going to specify a parameter. They're kind of like, you can kind of think of them like variables, but they're supposed to be passed in as arguments from when we call the function. And I'll explain a little bit more when we actually call this function. But for now, let's take in a parameter and let's give this a size of an unsigned integer 64-bit. We're going to specify the data type to be an unsigned 64-bit integer. And inside over here, we're just simply going to do the same thing that we did in the main function. We're going to declare a mutable variable called counter. It's going to, by default, have the value of 1. We're going to declare another mutable variable called sum. This is going to total up the sum after every single iteration. And then now what we're going to do is we're going to simply just loop, and we're going to check to see if counter is less than or equal to n. And if it is, we're going to do the same that we did before. We're going to reference sum, and we're going to assign it the value of sum plus counter, and we're going to have to update counter by 1 every single time. And if that condition is false, we're going to break. And all the way down here outside the loop, once we break, we want to return some value, but the question is, what value do we return? Well, in our case, think of it like this. Our function is responsible for summing all numbers from 1 to n. So it would make sense to return the sum. In our case, we have this variable sum over here that holds the value of the sum of all numbers from 1 to n. So we're just simply going to write sum down here, and that's going to return this value to wherever we call it. Okay, don't worry, we're going to go through this one more time. Before we do anything else though, we should actually give counter the same type, unsigned 64 bits. Otherwise, we're going to get an error. And let's go ahead and do the same thing with sum and counter like we did over there. And now inside the main function, let's go ahead and invoke the sum to n function. So to call the function, you just simply reference the function and you write out a pair of parentheses. Okay, this means that you're trying to call this function. Now, since this function, remember, it takes in one parameter, So we need to pass in one parameter. It's kind of like in basic algebra when you're dealing with a function like f of x. X in this case is the variable. It's one individual variable. You pass that variable into that function, and that function might add some numbers, it might subtract, do multiplication, whatever it is. And once it's done with its computation, it's going to return that value, and that value is going to be y. Okay, so hopefully that is a good analogy. So we're just going to pass in a simple number. Let's pass in 100 for now. But if we try to compile our code, it's going to compile just fine, and let's run it. But you're going to see that nothing actually happens, okay? We are calling this function. It is doing the execution of everything inside here. The problem is that when we return the value, we're ignoring the return value of sum to n, okay? So we can either do one or two things. We can actually just directly print this out. So we can do println, and then we can just pass this in over there. And if I compile the program again, you're going to see it prints out 50-50, as expected. If I pass in 1,000 this time, it's going to give us 500,500, and we can keep going. We can pass in 10,000, and you can see now I have my own individual function that takes care of adding all numbers from 1 to n, and we don't have to rewrite the same code over and over again. Now, let's say, for example, you might need this value later on at some point. So it's best to declare a variable that's going to hold the return value of that function call. So for example, we can call this variable sum and sum to n. Let's pass in 10, and then let's print out sum. Let's also annotate our variable to an unsigned 64-bit integer, since we are explicitly stating that this is returning an unsigned 64-bit integer. And let's compile, run our code, and you can see that right over here we have 55. And that's pretty much it for this video. Just wanted to do a quick video showing you guys how functions work, and we can do a whole bunch of stuff with functions. This is just a basic example, but I highly urge you guys to check out the documentation on Rust, and they have a lot of examples and they go in depth on explaining everything. And that's pretty much it. So I'll see you guys in my next video. Peace.